Okay everyone, section 12.4. This is a continuation of the last video on 12.3 counting principles. You need your calculator. I ended the last video talking about a baseball team. There were 9 people that were trying out for 9 positions. And the first question was, so this was the baseball, 9 people. Okay, and the first thing that you were asked, or the first thing I did, was said, okay, how many different ways can you create the team? Assuming that the catcher can also play the position of first base, can also play the position of outfield, etc. So this is no restrictions on who plays what position. And we said that that was 9 factorial. Okay, so this is going to talk about the sections about permutations. And the number one thing that you need to remember about a permutation is that order matters. Okay, so order matters. And what that means is the catcher and the pitcher is different than the pitcher than the catcher. So this is what I would refer to it as. If you're looking as like being in first, second, third place, right? Like gold medals, bronze medals, silver medals, etc. So if I'm on the podium, and then there's this one, and then there's this one, and we are talking about, you know, third place, second place, first place. Okay, so me, Titus, Portia, me being in third place, Titus being in second place, and Portia being in first place is different than me being in third place, Portia being in second place, and Titus being in third place. So when you think about like winning a race, like the Olympics, getting the gold medal versus the silver medal versus the bronze medal, order matters. So this problem with the baseball team, the person playing pitcher, catcher is different than if that person plays catcher than pitcher. Hopefully that makes sense to you. So AB is different than BA. 2 really common examples of this. Your class schedule. Having me first period and then having PE second period and having Spanish third period is not the same as having math or having like Spanish first period and then PE, you know, fourth period. They're different because you might get a different teacher and you'll probably have different kids in your class. So your schedule matters. The biggest place that a permutation happens, and it is like a major false advertising, is your combination lock. It is not a combination lock. It is a permutation lock. The order in which you dial your combination matters. If you dial it in the wrong order, your lock's not going to open. So from now on, when you see something is called a combination lock, that is 100% wrong. Order matters. It's not a combination lock. It's a permutation lock. So I think nowadays on locks, or at least it used to be, there were 36 numbers, but that didn't include 0. So technically there's 37 number choices. So you have a 3-number lock. There are 37 number choices. You can have repeating digits. You can have repeating digits. It is possible, it won't be very good, but your combination lock, your permutation lock could have the combination 0, 0, 0. 3 this way, 2 that way, 1 this way. So there are 37 times 37 times 37 ways that you, different combinations, which is 50,653. I recognize that I kind of left the baseball thing. I'll come back to it. what is the probability that your combination is, how about 20, 17, 13? So, how many ways can you get a combination of 20, 17, 13? 1. That's a lot, excuse me, that's a lot of different permutations that can happen. Okay, what's the probability? This is a trick one. What's the probability that you have 3 of the same number? So your combination is 0, 0, 0, 1, 1, 1, 2, 2, 2, etc. How many ways can this happen? Think about that for a minute. Push pause, give it a thought. The answer to this is 37. You can have all zeros, you can have all ones, all twos, all threes, all fours, all fives, blah, blah, blah. There are 37 ways that you can have the same number 3 times in a row. So that would be, I'm out of room, 37, 50,653. Okay? Okay, so let's go back to the baseball problem. By the way, this is number 16. Oh, I should not have erased that. Oh well. This is number 16, page 648. Okay. What was it? 9 factorial. Is that right? Oh, number 16 has 11 players. We're just going to deal with this. Okay, so I want to know how many ways, the number of ways that Julie plays first base and Johnny plays, let's say, left field. LF, left field. Wait, Julie, Johnny, where are they coming from? Who cares? Okay, it really, truly makes no difference. I could have said Portia and Titus. I could have said, Tom and Jerry. The names make no difference. We're assuming that someone named Julie is trying out for the team, and we're assuming that somebody named Johnny is trying out for the team. There are 9 positions, 9 people trying out, okay? So we're assuming 9 positions, 9 people trying out. And yes, we're assuming that there's only 1 Julie and 1 Johnny, okay? So you don't need to be so technical smartass about it. Because I know some of you are thinking that. Here we go. How many ways can Julie play first base? 1 way. I did this for the words in the last video with Arkansas and Portia and Titus. Okay, there's 1 way that Julie can play first base. She plays first base. There is 1 way that Johnny can play left field. He plays left field. The rest of the people, there are 7 people left, 7 positions. I don't care about these people. I don't care where they play. I just want them on the team. So this is the number of ways it can happen, which by the way is 7 factorial. 5,040. So the probability that you have a team with Julie on first and Johnny in left field is 5,040 over 362,800. If you're going to leave it this way, it's wrong. You need to at least reduce it, if nothing else. But I'm going to do the percent. 3,600. What did I do wrong? 1.4. You have a 1.4% chance that in this group of 9 people that Julie will be chosen to play first base and Johnny will be chosen to play left field. Okay? All right. So the thing you need to remember is that order matters when you are doing a permutation. Probably should have started the lesson this way. I didn't. There's actually a formula for permutations. Subscript N, uppercase P, lowercase r, and that stands for permutation. The number of options, you have 9 people, 9 options. Arkansas had 9 letters, whatever. Titus has 5 letters. That's your options. The R represents how many do you want, how many letters do you want out of Arkansas? How many positions do you want out of the softball team or baseball team or whatever? And this is n factorial over n minus r factorial. So, wait, Miss Babiak, there's a key in my calculator. Why do I need to know it? Because you should be familiar with the notation. You should be familiar with the notation. And on your calculator, I'll show you another way to do that. So the factorial key is alpha window, or you can do math. So on your calculator, type in some random number, 16. Okay, math, arrow over to probability, and then you'll notice that number 2 says NPR, so math, probability, depending on your calculator, it'll actually show up as like mine right away. I typed in 16 first. I just typed some random number. When I did 16, math, probability, and PR, my screen looks like this. And then I have a flashing cursor. So let's say you want to do 16. I have 16 things to choose from, and I want to choose 10 of those, let's say. That is a ginormous number. Woo! I just made this up. That's where I got it from. Totally made it up. Okay, it's, ready? 2.9, 059, 059, 4304 times 10 to the 10th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 29,059,430,400. That is a lot of different ways. It's a lot of different ways. Okay? All right. Let's just do, you don't always want to have to, like, you see how every problem I've written out all those spaces and I've filled it in? It's really not necessarily the most efficient. So let's just do one. I'm going to do 1/2 of one problem, and then I'll shut up for this video. Let's do, how about, how about 19? Take a look at number 19, and you'll see why I'm smiling. You got that right. Could not end the year without talking about Calvin and Phoebe. Yay! Okay, last one. I'm only gonna do part of it. 10 first graders line up for a fire drill, number 19. How many possible arrangements are there? Arrangements, that's the key word. There are 10 first graders. I want to choose 10 of them. This is the same thing as 10 factorial. There are 10 first graders. I want to choose 10 of them, and I'm cheating. The answer is, wait, am I doing the right one? Yeah. All right. Calvin and Phoebe, man, they're going to be at the front of the line. Okay, so how many of these arrangements have Calvin and Phoebe next to each other? So Johnny could be first, and then we could have Calvin, Phoebe, and all these other people. Or Johnny could be first, and then we have Phoebe, Calvin. Oh my God, this sounds very difficult, but I swear to you it's not. How many kids are not Calvin and Phoebe? They only wish they were that cool. That's right, there are 8. There are 8 students that are not Calvin or Phoebe. Yeah? So I'm going to arrange these 8 kids. So maybe it's Calvin, Phoebe, and then these 8 kids. Or maybe it is the 8 kids, and then it's Calvin and Phoebe. Or maybe it's 6 of the kids, Calvin, Phoebe, and then how many more kids are left? 2. Okay, so here we go. So not Calvin and Phoebe would be 8P8. I'm going to arrange the 8 kids, and I want all 8 of them, and I want to arrange them. Great. You would think I would know 8P8 off the top of my head. I'm so happy we have a Calvin and Phoebe problem. I didn't want to end the year without them. 40,320. Oh my God, that's a lot of ways to take 8 first graders on a field trip. Thank goodness I don't teach first grade. Think about that. Think about your first grade class. Think about 8 other, like you and your BFF and 8 other students. 40,320 ways your teacher could have arranged you. Okay. Now, there are, wait, hold on a second. This part's so creepy. Okay, then there are 18. Think of Calvin and Phoebe as one set. There's Calvin, Phoebe, and there's everybody else. So there's Calvin, Phoebe, the arrangement. So I'm going to look at them as one person. So there are 9 ways to throw them into the mix, but don't forget, Calvin and Phoebe is not the same as Phoebe and Calvin. So we have to multiply that by 2, which is where the 18 came from. 9, because I'm counting them as one person if they have to be next to each other in the arrangement. And then I'm multiplying that by 2 because Calvin, Phoebe is different than Phoebe, Calvin. And I have no idea, but it's a big number, I think. 40,320 times 18, I think. There are 725,760 ways that you could arrange the class such that Calvin and Phoebe are next to each other. What's the probability it's going to happen? Okay, so again, this represents arranging the class as long as, you know, our 2 BFFs are next to each other. There are 3,628,800 ways for this to happen. Wow. The probability that Calvin and the Phoebe Meister are going to be next to each other. 725,760 over 3 million. Don't you feel sorry for your first grade teacher right about now? I would. Divided by 3,628,800. 20% chance. There is a 20% chance that they will end up sitting next to each other. Oh, I feel so invigorated. We just talked about Calvin and Phoebe. All right, permutations. Order matters. A combination lock is a farce. There's no such thing as a combination lock. It's a permutation lock. All right, guys, one more. Permutations and, no, not permutations, combinations and probability. See you next time.